ditong car-robot. Ginawa kong project nakaraan. Ito, nalobat na siya. Ating i-upgrade yung power supply. May headlight, tail lights, motor, DC motor, gear, 4 yung gulong, yung circuitry niya sa ilalim. Meron pa rin dito connection sa controller. I-adjust natin yung boost converter sa 9 volts. Kasi yung battery 3.7 volts, i-step up niya into 9 volts. Yung output, gagamitan natin ng tester. Yung input, connected to battery. 20 volts range. So initially siya ay 3.44. I-adjust natin itong potentiometer. Gawin nating 9 volts. Yan. Nine volts. 9 volts na yung supply ng ating car-robot. Okay, dito meron tayong oscillator. Yan yung pinaka-logic control ng ating gagawing project. So yung isang channel, kulay dilaw at yung isa blue. Dalawang channel. Ngayon, ang ibig lang sabihin yan, i-offset natin yung blue. Mabagal na frequency. So pag naka-on yung isang channel, naka-off yung kabilang channel. On, off. On, off, on, off. On, off, off, on. On, off. Diba? Oh. So, makikita mo dyan. Alternate switching ng ating oscillator, yung PWM. Ito yung circuit na yun, no? Ito yung circuit na yan. Yan. Susubukan naman natin ngayon itong circuit na ito. Yan ay motor driver. Siya ay H-bridge. So gagamitin natin supply ay adjustable. Mahina yung torque niya. Starting. Okay. So, una, siya nagro-rotate ng counterclockwise. You know, oops, sorry. Counterclockwise. Patras yung ikot niya. Sa kabila, bukan naman natin yung kabilang channel. You know, clockwise siya, clockwise. Ito na ang ating car robot. Ating robot car. Nasa ilalim yung power supply. At ito na yung kanyang circuit. Dito yung kanyang controller. At ito yung kanyang motor driver, H-bridge. Ang controller natin, PWM. Diba? Lahat siya ay transistor. Wala siyang microcontroller. Ano na naman yan? Ito. Magkasama na nating ginawa yung circuit. Yung ating controller at saka H-bridge. Motor driver. Bakit meron ka niyan? Saan mo napulot yan? Ginawa ko ito. Tingnan natin Kabit natin yung supply para makita mo itong ginawa ko. At testingin na natin. Okay? now the circuit diagram or the schematic diagram of our project. Self-driving car robot, all transistor. It means we are using all transistor in a circuit for making this robot car. The only difference is we have this voltage converter. This is the one that is different. All the rest are discrete components with transistor. Two types of transistor. Small signal transistor BJT and PN type 2N2222A 1, 2, 3, 4, 5, 6 BJT and what 6? Only 4. 1, 2, 3, 4. Okay, 4 BJT and PN transistor and 4 power transistor BD139. Why we use this power transistor? Because we need a high current transistor that is capable of carrying the current of the motor. Because motor is a current driven device. It needs a lot of amperage or the amount of ampere. And since we have this 9 volts from our boost converter, we have now this 9 volt supply. We have the switch. This is a toggle switch. Okay, it is not a normally open switch. This is an ordinary switch, toggle switch. When you press it, it will turn on, and when you press it again, it will release the connection. That's a toggle switch. Why we have this voltage converter? This is we're going to use this converter in order to supply for our, what is the circuit? Oscillator. This is the oscillator. Okay, we need a 6 volts. We need a converter to isolate the oscillator into the circuit. The oscillator must be isolated so that it can work smoothly or properly. We need to isolate that, so I just need 6 volts. Converting the 9 volts to 6 volts. This is now 6 volts to the oscillator, and then into the input 9 volts. We have 2 capacitor. That's the stabilizer for the input, output, ground of the converter. Now we have this connection to the, what do you call this? This is a buffer gate. Also, this one is a buffer gate. The capacitor, or I mean the collector, is connected to the 9 volts of this buffer gate. Why is that so? Because in order to have a constant current to be supplied into the H bridge. So this circuit now is an H bridge motor driver. This one is PWM, or motor controller. It controls the motor. It drives the motor. This is motor driver, motor controller. That's a 2 different thing. Okay, in order to let us make a block diagram. So this is the power, 9 volts. In order to explain it clearly, 9 volts, it will now convert to 6 volts to be supplied into oscillator. This oscillator has 2 inputs. I mean 2 output. This one, Q3, transistor 3, and the other one here. Okay? So input 1, it generate a PWM signal. For this one, PWM signal, and for the other side, PWM signal. The only difference with the two is if this is high, what do I mean by high? On. The other one is off. So that's why in our oscilloscope we can see the alternate switching of the two output. When this is on, this is off. When this is off, this is on. Okay? On, the other one is off. If this is on, the other one is off. If this is on, the other one is off. Off, on. Off, on. Okay? And we have these two transistors. That is a buffer. It means when this is on, it will switch on the transistor, and of course it will also switch on the output. This type of a buffer is emitter follower. We are gaining a high current. For this is a current sense resistor, where it has a lot of current capability for this type of transistor configuration. So here we have two buffer. First buffer, second buffer. What is the use of buffer? In order to supply a constant current due to the transition of the PWM. When one is on, when the other one is off. Constant current to the H bridge. And the H bridge looks like this. If this is the switch, H bridge, the motor, that is the H bridge. A simplified H bridge. 4 switches. Okay? Going to supply into the H bridge. The other one also. So first, how do this oscillator function? This is a multi-vibrator type transistor oscillator. We can analyze this. Okay, let us analyze this. In theory, okay, since this is symmetrical circuit, what do I mean by symmetrical? All components are identical to each other. 1K, 1K to the collector, 20K, 20K, 470, 470 microfarad. The same with transistor. In theory, when the current flows into the circuit or the oscillator, it functions at the same time. It works at the same time. The current flows into the capacitor, switching this transistor on, and also flows into the other transistor, switching this transistor on. Since there is imbalance or different materials, or the manufacturing of the components is different, the theory is not applicable. It should be one that is going to switch or to turn on first. What if we're going to say that this transistor will turn on first? It will charge the capacitor, switching this transistor, and then fully turn on by this 20K, switching this on, and this capacitor is discharging through the collector, and the current flows to the R3, to the collector, to the emitter. So this is on. There is no output. Why? Because all the current flows into the ground. If this is on, this is off. If this is off, instead of current flows into the ground, it will flows into the buffer. So it will inject a current. It will turn on, switching on this transistor. Okay, the base, the emitter, and then current flows from 9 volts. 9 volts is the collector current, collector voltage. injecting now current sense resistor. All the current flows into this resistor. Injecting now a current into the first transistor, a power transistor, switching this transistor on. Since this is an H bridge, the operation is somewhat letter H. It will switch on this switch, and then motor, and then to the other switch. But how about the other line or the other buffer? It will switch on this one, and then to the other side. Okay, let us analyze that. What if this is the first buffer we're going to use? Switching this transistor on. Okay, so this is on, this transistor, and also switching the transistor at the top. So switching this on, it will, what is now the rotation of the motor? It is from negative to positive, so it is counterclockwise. Switching this on, and then to the ground. We are using all NPN type. Switching this transistor on, and then the other transistor on, causing the motor to rotate, then to the transistor to the ground for this buffer. Since this is alternate switching of transistor, what if this one now is on? If this one now is on, it will inject a current to the other transistor. Switching this on, and then the other one to this transistor, switching this on. So the current now flows from collector to emitter, and then to the positive side of the motor. Rotating the motor moves it in clockwise direction, and then to the collector emitter of this transistor. So this transistor is injecting a current to this Q5 transistor and into this transistor, making the current to flow into the positive to the negative. What is now the role or the function of this diode? Since this is a motor, it has a tendency to produce a back EMF. When the current flows here, since this is a coil, it will produce a reverse direction of a voltage into the circuit, damaging this transistor. So instead of going to the transistor, it will flows to the diode, and then to the transistor, and then to the ground. Also here. That is the what we call a flyback diode, a clamp diode, to protect the transistor from back EMF, a voltage produced by the motor, reverse voltage. So that's why it turns on and off, because of the PWM, and reverse direction of the motor is due to this H bridge. That is the operation. We need this biasing resistor, of course, and then here, buffer, and we have this power indicator, just to know that our circuit is on. So that is how the circuit works. The supply, the PWM, injecting the buffer on. The first buffer is on, injecting to the H bridge. The two transistor now is on. Could be here to here, and then the other buffer is off. If this is now on, it will now continue the buffer one is on, it will continue the H bridge to operate. Okay, so that is the operation of the self-driving car robot. All transistor, no microcontroller.